What's up, guys? My name is Michael Lin. Welcome to my YouTube channel. And I know today is a very unconventional live stream time. Normally, I live stream at like way later at nighttime, right? But today I'm live streaming from my time, which is in the afternoon. So yeah, this is a very unconventional live stream time. But I couldn't live stream in the morning earlier, so that's the reason why. But yeah, today we're gonna try to solve Codeforces round 659. Which is one of the rounds which I didn't get to participate in. I also didn't get to participate in Codeforces Global round 9, so I'll probably look at that later also. So yeah, I'm gonna try to change up my live stream time to be in the mornings. So for me, it would be like 9 o'clock Eastern, but for you guys, for people in India, I think it would be. So from now on, I'm doing 9 o'clock Eastern to India. For you guys, it would be like 6 o'clock, I think. Yeah, 6:30. Let me see what time is it right now for people in India. 11 a.m. Huh. Maybe that's a better time. I don't know. But yeah, this is my time where I'm live streaming, and there are 5 people in the chat. I didn't know that. Okay, that's cool. I thought like most people don't really I thought this would not be like a good time to live stream because it's kind of middle of the day for me, but yeah, I don't know. But anyway, we're going to try to solve 659, and we're gonna try to solve all the problems. We'll see for this, okay? Because I haven't really seen any of the problems before, so yeah. I know this is a very unconventional time, but it's 11 p.m. Dang. I hope I'm not keeping you awake at 11 p.m. right now. But yeah, it's alright. I'm gonna try to change my live stream more earlier to the morning. So yeah, I'll try to live stream earlier. So don't worry, guys. Tomorrow I'm gonna push his live stream to a different time. So I'm gonna live stream at a different time. But yeah, currently in the past few days I've been kind of busy with doing research, so I didn't really have much time to do like stuff like that. So I've been doing stuff, computer graphics stuff. So yeah, but yeah, I haven't really had the time to upsolve. So maybe we should try create another live stream of upsolving. I don't know. Depends on how long this takes. Really depends on how long this takes. Okay. By the way, can you guys see my screen? Oh, okay, yeah. Alright, we'll give 9 more seconds, and then we're gonna try to fix this. We're gonna try to do the, not fix this, we're gonna try to do this contest. Okay, common prefixes. I think have I clicked on this before? I don't know. Length of the longest common prefixes of 2 strings is defined as the maximum integer k between the length of n and m, such that s1, s2, sk is equal to t1, t2, tk. You initially has n+1 strings. For each string, she calculated the length of the longest prefix. Okay. Several days later, she found these numbers, but couldn't remember the string. So Cora wants to find strings S1 to Sn+1, which would have an to a of n. Can you help her? Okay, let's actually just read in the test cases first. I should create some macros so that I could just read in the test cases immediately. That'll be another time. Because I know some coders just have like read in test case. I have a function that just does all this for you, so then you don't have to keep doing it over and over again. Read in n. Read in n, read in n, t n, and then read in vector n. So let's do vector a. Is it indexed from 1? It is indexed from 1, so let's do n+1. Let's read in of I. Okay, so now we do that for each test case. Output n+1 lines that consist of lowercase numbers, length of the longest common strings of si and si plus 1 that is equal to ai. What does that mean? Okay, hold up. Zero, 3, okay, first one is possible is AERENARIAROUSAL and O around RE. Let's see. Lengths of the longest prefix, common prefixes are A1. Okay, so A is 1. Okay, so that's where the first array 1 is. Between RE and arousal, it's 2. Between arousal, around is 4. Between around RE and around is 2. So, can we, so for the first 2 is 1, the second RE and R is 2, fourth around, fifth is 2 is between around and RE. So like 1, 2, 3, 4, 5. Let's see. So do they want us to generate these numbers? I think, what if we set them all to have the same, does it matter about the length? Let's see, does it matter about the length? I feel like we could just, so I feel like we could just add strings to it, you know what I mean? So like if it's, so like instead of doing these letters, so we need to have 1, 2, 4, 2, right? So between 1 and the common prefix between the first 2 is 1. Between the second 2 it's 2, right? Here between this one and that one it's 2. Or is it between all of them? Wait, 1, 2, 3, 4. Maybe it's between all of them. Wait, okay. Third one is 4. So from here to here. Oh no, but then if it's between all of them, the last one should be around also. Arouse. It's not true. Fifth one is R. Let's look at this again. Calculate the length of the longest common prefix of si plus 1. So it's only between the first and the second. So, yeah. Okay, so what I'm going to do is I'm going to get the longest value, find the longest number first, then I'm going to just populate all the values in the array to have A, B, C, D, E, F, A, B, C, D, E, F, up to the longest number, right? So they're all the same. Then for each of them, I'm going to change it based on the current common sequence. You guys understand what I mean? So like, here's my idea. I'm gonna get, so like if I have let's say I have 1, 2, 4, 2. So let's say I have this, right? Let's say I have this array. What I'm gonna do is I'm gonna find the first four, the 4, which is the largest value. I'm gonna populate my array to have like A, B, C, D, A, B, C, D, A, B, C, D, A, B, C, D. Okay? Then based on the numbers, the original, I'm gonna loop through the numbers again. Then for each of them, if it's like 1, I'm just gonna change all the values to have different values. So if it's like, this is 1, right? I'm gonna change A, B, C, D, and A, B, C, D. I'm gonna change this to have A, C, C, D, C, D, right? Then from here it says 2, so I'm gonna change this to be have a C, C, C. Wait. So A, C, C, and A, C, C, right? These I'm gonna change this to be become like D, and this become like D. Wait, hold up. Yeah. Okay. So I'm gonna change it so we need 2 of these to be the same. So we have to change like this to be different. So D, E, yeah. So like I'm gonna keep increasing the letter count by 1, like the current occurrence of the character by 1 for all of them, right, until we have like the same number of characters are repeating, like A, C, right? And then when it's 4, let's see. 4, you have to do, you have to add more characters. So you would have to have like D, E, F, 1, 2, 3, 4. And then this you'd have to change the same one, A, C, E, E, F, 1, 2, 3, 4, 1, 2, 3, 4, yeah. Then the last character you have to change, so F, G, right? And the 5th one, we just copy the same letter here, but we have to change them to now be 2. So we have to have 2 letters that are the exact same thing. So it would be AC and AC. So this would have to change to FDG or something like that. Yeah. So that's how I'm planning on doing it. I think there might be a better way to do it, but for now, that's how I plan on doing it. Okay, so first, technically, we don't need to index from n+1 because it has nothing to do with, nothing to do with the values. Okay, actually, maybe it's better if I put them all with A's first. You know what I mean? Yeah. It might be better if I just put all of them with A's first. What was the problem with this? Uninitialized memory of n. I don't know what the problem is at. Okay, so I'm gonna do like a function called solve. Let's put this in as a global variable. What's the problem with this? Oh, whoops. Yeah. Okay. So now we have that. We're gonna have solved. Maybe I should make string, not the string. Yeah. Okay. So right now I'm gonna do is I'm going to take. Did they say 4 or 5? Let's see. Well, I'm gonna do n+1 letters of one that are the same. So I'm gonna do like. This is going to be a string. This is going to be the answer. I don't know. It's going to have values of n+1. Maybe I should. Yeah, I should make it n a global variable also. So then I don't have to deal with all this nonsense. What's the problem with here? 9 overloads using initial values. Oh. Okay. Whoops. Yeah, now it works. So now we have n. We're going to create a value of n plus 1. I'm going to fill all the values in the array with the same letter. So currently, maybe I'll just fill them all with A's. I don't know. But we need the largest number. So for this one, largest number, say -1. Let's say largest number is equal to max of AI, largest number. Okay, so now, okay, I think it should be that. Actually, to make it, okay, that'll make it much better to read. Okay, we need largest number, so let's create a max num. And then here we'll do, yeah, we'll just do largest number equal to -1, and then do all the max num. Okay, so now we have largest number, and now what we're gonna do is we're gonna populate this whole array with a string of the same character, let's say A, and then just have the size of largest number. Okay, so now all the values are gonna be A's. So yeah, I'm doing the exact same thing what I said here, but I'm gonna fill them all with A's first. So this is gonna be like AAA, 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 AAA. Okay. And what I'm gonna do is I'm going to, for each of the one that is like, for each value of I plus 1, we need to get only one common character that's the same, right? We need to get change our array to have it the common character, common prefix, right? So so if it's all A's here, I'm gonna change the second one to BB, right? And then from here to here, I'll just copy AB to there, right? Because then 2 of them are the same. And then for 4, I'll just do like AB, AA, 1, 2, yeah. And the last one, only 2 of them are the same, so I'll do like 1, 2, 3, 4. I'll just copy the AB. Yeah, and then I'll change this to C or something. So yeah, this is what I would do for my algorithm, if you think about it. So once we got the largest number, we need to think about, we got to go through our I have to go through the array that has each of the common the prefix number, I think. You know what I mean? So like, I have to go through my array A, the longest common prefix of that. So yeah, what are you guys saying? Words per minute, I don't know. I've never actually tested that. There's like different typing programs you could do if you want. But yeah, for now, let's go back to here. I don't know what my words per minute is. Thanks, by the way, guys, for motivating me. I'm on the grind also. Okay, AI. Now we need to, okay, so we're looping through. So right now we're looping through all the values of AI. So then in this case, it would be 1, 2, 3, 4. So we're gonna add 0, 1, 4, 1, 0, 1, 2, 3, 0 plus 1, 1, 2, 3, 4. Okay, so we only have to change the rightmost value. So we could do answer at I plus 1, which is the rightmost value, right? And we need to change that string to have a different character. So in this case, the index is 0, 1, 2, 3, 4, right? This array is indexed like that, and this one is the same thing, but it's 0, 1, 2, 3, 4, and we need to populate this, right? So if I go through here of my array A that has a common prefix, I could go I plus 1. Actually, no, I can't do I plus 1. Can I do I plus 1, 0, plus 1, 2? I'll go over. Oh, wait. Why do I have an extra 4 here? Yeah, I could do I plus 1. So if I loop through from here, my excuse me, answer array, and start from 1 to go to the end, and then for each of the 1, I'll just check this. Yeah, that'll work. So I'm going through my size array for this one. So I'm going through here, and I'm gonna check I plus 1, which is gonna be 1, 2, 3, 4. And then for those values, I'll change the character. Okay, so I think that makes sense. So answer at I plus 1. I need to change this. So I have to do like a so this is the number for common. The common number of values that are the same is A at I. Right, so I need to keep those values for I plus 1 for my answer that are the same up to common. But from common to the right, I change those. Okay, so if it's, yeah, okay. So if it's, so answer at I plus 1 is going to be, let's go back here. So in this case, I want one value to be the same for both of for at 0 and 1 for my answer array. So that would be A and A have to be the same. So that means from 1 and 1 to forward, I have to change this to be different. So yeah, I think I got it. So I would change one character to be different from at position 1 to the right. So if it was, let me try to think. So if it was, so if AAAA, ABAA, I would change one character at position of 1 to be B. Yeah. Then at 2, I need to change at position 2, 0, 1, 2 to be C. Yeah. So I would keep the first two, but the right one, I'm going to change it to a different value. So I would change it to like C or something. So I change this to be like C. Okay, so I think I got it. So at the right value, I'm going to change whatever position at this position, this number, I'm going to change it to something else. So I need to take the I need to find the value at the previous value at common. So what is the previous value at common? That's yeah, so I need to find the character at the previous value at common. So this is going to be letter, previous letter is going to be answer at I at common. Yeah. So in this case, 0 and 1, previous letter AA is a common value, right? So then the second one, I'm going to change this to be like B or something. Yeah. So I'll take this one and this one, at position 1, I'll change it to like B. So I get the last previous one, which is A, and then I need to add 1. So this one, I'm gonna add this to be 1, but I need to loop it back to the beginning for 26. So I need to mod it by 26 also. Okay, so then I need to do next letter is going to equal to answer at, it's going to be previous letter plus 1. I want to see if this works. Let's see, go through the next letter of the alphabet. Static cast. That's cool. Static cast. Static cast. Hold up. Let me try something. Should I use static cast? I want to mod it by 26. Let's see. Let's look at the ASCII value. Okay, so we have A, B, C, D, E, F, G, go up to Z. Let's say I get up to Z, add 1. Then I'm back at 123, but I want to go back to A, so I need to do. If you 123 mod by 26, what is that? Because at Z, like A, B, C, D, Z, 123, I want to go back to A. So I need to 123. Let's see, 123 mod by 26. I could do 19. That's not right. I need to add it by 97. Is that right? 116. Is that? No, that's not right. I need to figure out how to wrap around. So A is 97, 98, 99, 100, 101, 102. Mod by 98. Mod by 97 gets you 26, which is going to go back to the beginning of 0, and then I add by 97. So no, wait, no, that doesn't make any sense. Go back to 0. Okay, so mod by 97, go back to 0. Wait, if you mod by 97, does that go back to 97? It goes to 26. Ah, 96. That'll bring you to 27. Then I could do. Oh, I'm trying to think. How do you increment letters? Okay, I'll just do this. All right. If letter is equal to Z, I need to set the previous letter back to A. So next letter. So I need to create next letter here to A. Otherwise, I'm going to set next letter to equal to previous letter plus 1. Okay. If this doesn't, I'm not sure if this works, but we could use a static cast later. Should we use a static cast now? This is just to make sure it works. Yeah, let's just use that as to make sure it works. Okay. Yeah, if it's equal to 0, z, we'll set it back to a. Otherwise, we'll do that. Okay, so now we have the next letter. We just need to set the answer at I plus 1 of the common number at a of I, and set that to be the next letter. I don't know if you could do this, but I'm assuming, I think in C++ strings are an array of characters, so I think you could do this. Okay, so I think this should ideally work. So we get the next, we find the common number in both of them. We get the next letter, the one afterward, and we change it. Yeah. Let's just let's go through and then print out our values and answer now. I think this should work. I think I talked way too much in actually coding. It's not like I'm not doing this seriously. I took 31 hours, 31 minutes of talking. Okay, something went wrong. Something went wrong. Why can't? Did I even copy it correctly? Yeah, okay, something definitely went wrong. Alright, let's see. Let's go back. Okay, let's do some minor debugging. Oh, I didn't set the values to be a correctly. Wait. Hold up. Pretty sure the string constructor works like that. Oh, maybe it's opposite. It's the opposite way. Sure to give me all A's. Whoops. Yeah, now it's all A's. Okay, so that's right. Okay, next character should be, previous is A, next one should be B. Yeah, I'm gonna set it to B. Okay, so that's right. Okay, so you have A, B, A, A. So currently now we have A, B, A, 0, 1. Okay, common number is 2, I think. Whoops. Previous letter is A. Is that right? Yeah. Yeah, it's right. We change it to B. Okay, so now we have A, B, A. So now we have, let me move this up. So we have A, B, A, B, A. Oh crap. I have to copy the strings before it. Otherwise it's not the same. So I have to copy the strings before. I have to set A at I plus 1 has to now equal to answer at I. Yeah, so I have to copy the current string is equal to the previous string, yeah. So I hope that does a deep copy, not a shallow copy. I think it does a deep copy because equals does a deep copy. Now let's do this again. Okay, so we have A, B, A. Yep, that's right. So now we have A. We have A, B, A, B, A, B, B, A. So these two are two common prefixes. Yeah, two common prefixes. Let's look at our answer. Oh, no, not that. There should be, yeah, two common prefixes, and the next one should be 4. What is the next letter? Ah. Oh, that's bad. Okay, we went out of bounds in our array, in our string. Yeah, let's fill the largest number plus 1. Yeah. Okay, so now we're not going to go out of bounds because we know it's the largest number plus 1. So now it's 5 characters. Okay. Okay. A, B, A, B, B, A, B, B, A. Okay, so let's see. One common prefix. We have 2 that are the same. We have 3 that are the same. Oh, we have 4 that are the same. Yeah, that's right. 4 that are the same. And then we should have 2 that are the same in the end. So that should be, yeah, okay, so that should be C. Okay, I think this should work. I actually think this would work. Yeah. Do they have to be, I don't think it says they have to be different characters, right? Yeah, I don't think so. Yep, we got accepted. Okay, that's good. Next problem. That was more me talking. Every problem till they have solved or an ASCII table has melted. Yeah, ASCII table is pretty difficult. I have not participated in that many contests, so I would not. My rating is pretty trash. It's like 790-ish. So yeah, my rating's trash. But some problems I could solve 2, some problems I could solve 3. Sometimes I solve 1, sometimes I solve 0. So yeah, it kind of fluctuates. Okay. Oh, the only difference between the easy and hard versions is the constraints. You have to make sure the hacks only if all the versions of the problem are solved. Okay. N plus 1 meters of a sea, N plus 1 meters from the shore. You measure the depth of the sea. Measure the depth of the shore. Any beach of the tide is a biparameter K affects all depths from the beginning at time t equals 0. For a total of k seconds, each second tide increases all depths by 1. Then for all total k seconds, each tide decreases by 1. What? What? I'm getting water. Gotta take a walk break. Hold up. Okay. So many symbols. Let's see. let's read in T and K L and then D and then yeah, then we'll try to understand this because there's too much reading. You guys, whenever you solve these problems, do you look at the thing and then realize there's way too much reading here? That's what happens to me. Okay, T, N, K, L, okay, so T. Let's make these global variables so then I don't have to keep passing it into the array. Let's remove our previous code that we don't need. We need an array of D values. Okay, so now we have that. Each consists of L plus n plus 1 meters of sea and an island n plus 1 meters from the shore. She measured the depth of the sea at 1, 2, 3, 4, up to n meters from the shore. Save them in the array of D, which is the depth of the sea at the ith meter from the shore. Any beach like this one, the intensity of the tide is measured by the parameter k and affects all depths from the beginning at time t in the following way. For a total of k seconds each second, the tide increases the depth by 1. For a total of k seconds each... Wait, what? Tide decreases all depth by 1. Wait, what does that mean? I mean, if you increase depth by 1 and decrease depth by 1, you're back at the same depth, though. So find the array P is equal to 0, 0, 1, 2, 3, up to k minus 2, k minus 1 down to k, then k minus 1, k minus 2 down to 1. Okay. T mod 2k. Okay, so she starts at 0. Oh no, she starts at x from the shore. Oh my gosh. Okay, you start from x from... Okay. This is just... Oh, my bad. This is just all nonsense. Okay, they're basically saying that you're going to concatenate... You're going to increase... You're basically increasing your values up to k, then decreasing it down back to 1. That's all they're saying. That's what this is. Okay, that's what this array is. So then add a depth of let's say time t, it would equal to the shore plus mod 2k, which is the remainder of the time when you increase up and then go down. Okay, so yeah. Now you're gonna start. Koa starts at time t, so he's at x distance already from the shore. So he's at a distance in the shore already. So you could either swim 1 meter away from the shore, not swim at all, or wait, what? Wait, you can't swim backwards? Swim away from the shore. Wait, what does he want to do? She wants to get to the island. Oh, okay, she wants to get to the island. Okay, so the island is further away from the shore. What, did they tell us how far the island is? They tell us the depth of the sea. Okay, so the island is at n plus 1 meters from the shore. Okay. Okay, so you could either go further away from the shore or you could not swim at all. But Cora is a bad swimmer, so the depth at the sea, where she is at, can't exceed L points of time. Wait, what does that mean? The depth at the sea at the point where she can't exceed L at integer points of the time or she will drown. So I'm X away from the shore. The depth, I could stay at my current location or I could move further away, closer to the island, right? The depth at the point cannot exceed L points of time. So the depth at the point minus dx plus pu can't exceed L. So my depth the depth of the sea at that point where she is can't exceed L points of time. Do they mean by T then? Oh no, the depth where you're at. Okay. Is always less than or equal to L. Okay. So the depth at the sea at this point minus dx plus p of t mod 2k can't exceed L. In other words, d of x plus p of t 2k. Okay. So, I think I understand this problem now. Okay, so we have a bunch of... We're at a certain distance from... So there's an... Okay, so we are at a beach. There is an island that is n plus 1 meters away. The shore rocks back and forth, right? So it would increase up to each depth from like 1 meter of the shore. There's this ocean's depth is like goes up and then goes down, right? So that's what this is, right? And it rises all the way up to k and then it drops down to 1. That's the depth. So we have the depth of each ocean, but we also have the tide that oscillates. We could stay at a current location, and we could move one distance closer to the island, right? So we're at X distance from the shore, from the beach. We can move one, or we could stay at where we are. But the issue is that we're a bad swimmer, and the depth at our current value, where we're currently at in the ocean, ocean depth where we're currently at, has to be less than or equal to L. Okay? Once we reach at n plus 1 from the shore, she stops and rests. The tide doesn't have an effect on her. She can't drown while swimming. Okay, so so what they mean is that the tide can't, while we're swimming, the tide's not gonna drown us. Okay, so if we're swimming, this is such a tough problem. Okay, so if we're swimming over, my gosh. Okay, so yeah, we need to create a length p that defines the tides of length 2k. Yeah, okay, so we need to create a length of that. So that's easy. So let's do like a vector p is going to equal to vector 2 times k. And to fill these values, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to k. And then k minus 1 down to 0. Okay, so we could do that. We fill these values from 0 to k, then k minus 1 down to 1. Oh, down to 1, not 0. Okay, that's weird. Okay. So we fill from... is going to equal to I. Okay, so we fill all the values from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to k. Now we need to fill from... I need like an index. Yeah, I need a current index. Index plus plus. Okay, so we fill all the values 0, 1, 2, 3, 4, 5, 7, 8, 9, 10 up to k. We need to start from k minus 1, go down to 0 now. So we got to do k minus 1. Yeah. Might be an issue with the index here. Do I have to add one more? Let's say I'm at k. No, I don't. No, I don't have to. So now here we do p at index is going to equal to I, and then index plus plus. Okay, so now we filled all our values with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to... oh, we have to go to 1, not 0. Oh, that's weird. That's super duper weird. Okay. Yeah, go up to 1. When it's 0, we don't do it. Yeah. Yeah. Okay. Now it's the hard part. How do you come up with an algorithm for this? Swim x plus 1 or not swim at all. Because like is the depth changing? Because if the depth is not changing, if the depth is... because like if the depth is not changing, we just get stuck in the middle of the ocean once we reach up to L. You know what I mean? Oh wait. Oh. 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 Okay. Yeah, so we probably won't. So we could probably... so... oh, we're printing yes or no if we can reach the island or no otherwise. Oh, okay, okay. That makes more sense. Okay. Oh, excuse me. Oh my gosh. I need to fix my sleep schedule. If we're oscillating up to... oh, this is a 1900 problem? I didn't know that. That's a division 2 though. If we're oscillating up... Why does the beach look like 2, 1, I? I thought the depth doesn't change. You start from it's affected by tide. Okay, what if we just use a basic greedy approach first? We just keep going straight until we drown. What if we do that first? Okay, so what is so p of where's the thing? Where's the formal definition? Excuse me. So I'm gonna keep going straight until I drown, and then I'm sure there's some I'm sure the basic test cases would work for that. Basically, I'm gonna keep going forward until my current value is greater than L. Then I drown. If I don't reach to the end, I'm just going to print out no. Otherwise, I print out yes. Okay, so this let's try like a greedy approach first. So like this is really difficult. We should index our depth at. Did I even read my depth array? I didn't read my depth array. We should read this by index it from 1. Okay. Let's see. The ocean. I'm so hard. Yeah, fair enough. Okay, so are we at X? Do we read an X? What do we start at? Hold on, where do we start at? Number of meters of C measured K and L. Wait, number of meters of C. Does he tell us where we start at? We start at. Oh, we start at the shore. Okay, so what I'm gonna do is I'm just going to keep going straight until we die. So, all right, we start at 0, and I'm just gonna keep going up. So, yeah. I'm not sure if we need T, but I'll just use that currently. Yeah. So, whoops. While, let's do, is this a minus sign? I don't think so, right? Okay, while d of x plus p of t mod 2k is less than or equal to L. That's just x plus plus t plus plus. Then if x is equal to we have to get to n plus 1, right? Print yes, otherwise print no. So I don't have an idea how to solve this yet, so I'm just gonna try a greedy solution and see if this works. Who knows, it might work. Maybe you just always die. Maybe you never die. Yeah. I got out of bounds. X is less than d dot size and t is less than p dot size. Okay, so let's do this. Okay, yeah, okay. I have no idea. What do you guys think? I only could think of... Okay, let me think. So if we get to a case where we can't move, like it's the depth is too greater for us to handle, we could wait and add t by 1 and then see if the depth could still move. Yeah. If we're stuck there for a while, then we just print out number of seconds that we're stuck there. I don't know. I don't know actually. Well, this is a hard contest. How's this Division 2? C is the exact same problem though. Oh no. Oh, maybe I should try C. Okay, You have two strings A and okay. In one move, you select a subset of positions such that they're equal. You select Y greater than X. Set the letter of the positions to Y. Smallest number of moves she has to make the string equal to 0. I want to see what are the current standings. It took me half an hour to do the first one. Oh wow. Someone got B first, then they got A. Huh. That's actually kind of surprising. I thought A was easier than B. feel like we should keep trying on B. I feel like you could definitely do it. So like my idea is that you stay at the one location. If the depth is too much, we stay there, right? We keep going forward. If the depth is too much, we stay there. If it doesn't work after a certain number of seconds, where the tide is still above us of the depth, we just print out no. So like we could do like a simulation from 1 to a million or something. After like W number of seconds or something. But yeah, let's see. Why do I have an out of bounds error? You have no. Do all of them not allow greedy approach? I know greedy fails, but why would all of them not have a greedy approach? I'm really trying to think. I'm trying to think. Gotta think. And we have 55 minutes left. How long have we been live streaming? An hour? I don't know. Maybe we should try this. Should we try the string transition? I feel like this is a. I feel like the first B1 should be pretty basic. You know, like you just stay there. Okay, so let's say you wait 1 second. Okay. We are going to debug this, and we're going to figure this out. We are going to figure this out, guys. We have to. Was it 7211? Okay. Let's create our vector. Wait, our p-value isn't even right. Is it? How much is our p? Why is it only 0, 1? Oh, it is 0, 1. Oh. Okay. Initially at 0, the beach would look like 1, 0, 0. So at 0, it's 1, 0, 0. Yeah, okay. So, let's see. T plus 1, x plus plus. Okay, so at the first one, so we moved up 1. So we moved up 1. It doesn't drown. Wait. At 0, we should decide to do x1. Beach looks like that. It is greater than, so we do drown. So now we're going to wait 1 second. Okay, I got it. So what we're gonna do is, okay, so I'm gonna do this. If this is less than that, less than L, we're going to increase 1 x plus plus. If it's not, so if it's greater than, we are going to pause. Let's see, t of p of less than size. Actually, this doesn't matter. We're gonna pause. So we're gonna do t plus plus. So only the time increases, but if t plus plus reaches like, let's say threshold of 1 million, we break. If t is equal to 1 million, we break, and we say an impossible. Right? So if t is equal to possible, now we said possible is equal to false. Actually, we don't even need a possible. When we break, we just see if we're actually at the threshold. Okay? Okay, so let's see if this works. Okay, so damn. Will I stream after the virtual participation ends? Maybe. Actually, probably not. After this, I don't think I'm gonna stream again. Like for today, I'm not gonna stream again. Maybe I'll try to solve another problem. Oh, I have a new message. I do read the chat. Yes. Yes, I do. Oh, maybe I shouldn't put this on. I really should not put this on the thing. Okay, now I think I have to think about blurring out. Do you guys mind if your names are on in the live stream? I don't know. Yeah, this is very hard. Very hard problem. I didn't even know it was 1900. It's kind of crazy because like I have solved problems that were way harder. Like, let me see. Like I have solved problems that were hard randomly before by doing some of the code drills, and I didn't even know they were. Yeah, so I have solved F and E before. I just haven't like. I didn't know they were that hard though. But after reading the editorial, I have solved them. Yeah. Maybe I should practice more problems of like 1200, 1300 to increase my ranking. Maybe I should do ladders. Is there AO3 ladders? A2OJ. A2OJ? I don't want to read that book. Oh, it's ladder. Ladders. Huh. I don't have the... I don't think I have 100 problems. Maybe I'll do ladders. Okay. I'll do that later. I'll create an account later. Okay, back to this. Yeah. Do I... So, yeah. If I reach a threshold, I stay there. We break. Well, let's see. Will this work? Damn. Oh my gosh. Okay. Yeah, we'll move it. We'll increase. Okay, so the first one did yes. Ah, damn. Oh my gosh, I just reran it. Yeah. Let's see. Let's change the breakpoint. So yes. Oh, now I'm getting yes for everything. Okay, that's not right. That's definitely not right. Definitely not right. We need to reach n plus 1. Second one should be no. T is 4, X is 3, she made it. Let's, oh boy. Let's see if we got that. Okay, so this, T is 1, doesn't work. T is 2, and T is 1. 2, 1. Two, X is 2, hold up. X is 32, X is 4, 3, 4, 3, she made it. T is 4, 3. I think that's right. Let's look at the second one. Let's look at our p-value. One, 2, 1. Is okay 2. 0, 1, 2, and then back to 1. Yeah, that's right. Okay. 0. It's not our threshold. X is 4. X is 5. Oh boy. That's alright. It's impossible to beat it. Okay, are you allowed to use Stack Overflow, etc.? I mean, during a virtual participation, no one's gonna stop you. You know what I mean? During a contest, I don't think you should use Stack Overflow. Because you're testing your ability to solve the problem. If you use Stack Overflow, I don't think it's a good idea. Unless you're doing it just because you forgot like a part of a language, like a library, and maybe you should use it. But I mean, technically, no one's stopping you. Use Stack Overflow whenever you want. Only when you start cheating. I think my first contest, I actually used a calculator to try to solve one of the problems. I think that was fine. Let me see. My very first contest. Yeah, this one. I used a calculator to try to come up with this equation, and it worked. You know, like not like I didn't use it. I didn't use like a linear regression. That's not what I mean. But I tried a bunch of values, and then I was like, oh, this is the equation that would work. It's like n times n squared minus n minus 1 squared. And I said, oh, okay, this works, and it worked. But yeah. Kind of crazy. It was like a one-liner thing. See other people. Yeah, everyone uses like a different for loop or something. But yeah, it is what it is. What it is. I might actually pull up 2 computers, so then when I have a live stream, I don't have to show you your guys' names. So it's more privacy. One to read the chat, the other one not. You know what I mean? Oh boy. Okay. I am stumped. I am stumped on this problem. Let's see. I don't know. A lot of people use. I mean, I don't think it. I think it really matters. You could use Vim. Vim is like a text editor. But I don't know. I don't think it like improves your speed or whatever. I mean, you would have to use GDB to debug, right? If you're using Vim. You have to use this if you're gonna use Vim, right? Like, what I like about Visual Studio is that I could just do, you know, go to the line, go line by line, shows my variables. Like for Vim, you would have to use GDB. And you can't really see your variables. You have to do like print variables, print, stop, break, clear, you know, type a bunch of commands on the Linux side. Yeah, like this. You'd have to be like print, where am I? Stuff like that. Sometimes it even shows you the assembly code. I find, for me, I find this unreadable. But some people enjoy using it. Like for me, if I look at the debugger here at the output, I could actually look at the variables and what's going on. I go line by line. But if I use Vim, my head hurts. My head starts hurting. Okay, this is too difficult. We are going to go to the third problem for the last 30 minutes. Okay, we have 2 koala bears, 2 strings A, B of the same length, 20 lowercase English alphabets, A to T. A to T? Okay, that's weird. Okay. You select a subset of positions such that A at the positions equals to X. Okay. You select the first Y such that Y is strictly greater than X. Set each letter in the positions to Y. You want to find the smallest number of moves to make them both equal. I don't know. What do they mean? Hold up. Select a subset for TP of subset where they're not equal, and you set all of them to the same letter of X. You want to find the minimum number of moves it takes to make them both equal to each other. Let me think. Trying to think. A, B, A, B. Would it be the one that the most occurs? Excuse me. Yeah, I don't know. Alright guys, I think I'm gonna end the live stream right here. I hope you guys enjoyed this live stream. I solved one problem, the other one I couldn't solve. But yeah, sometimes you just have to cut your losses. Yeah, I'll look at the editorial for B1 later. But yeah, hope you guys enjoyed this video. Rate, comment, subscribe. I'll check you guys later. Peace.